Okay, we have a short lesson today called linear problem solving. Um, Basically, this is just word problems with linear equations. You all know how to do linear equations already, especially because you've been through Algebra 1. Um, and so these are just word problems that go along with this. Some keywords to look for is like in this example, it says a machine salesperson earns a base salary of 40,000 plus a commission of $300 for every machine he sells. Anytime it says for each, per, all that means you multiply this number times a variable. So it tells you that he's selling X machines, and so you're in your equation you have 300X already. Okay. Then your keyword here is plus. Your base salary is 40,000. And so it asks us to write an equation that shows the total amount of income the salesperson earns if he sells X machines in a year. We've already accomplished that just by translating the question. Anytime you're supposed to add, it's going to be plus. It could be the sum of. Anytime you're supposed to subtract, it's going to be minus or difference. Anytime you multiply, it could be for each or for every or per. And then division is going to be quotient. So it'll be like the quotient of 40,000 and 10 is, or 40,000 in a variable is something like that. Okay. The other type of question, or the second type of question, will be like this. And this would usually show up in an open-ended. So it's an easy open-ended question, but it just takes some translating to get through. So then you would have a second part to it. Linear model that shows the total income for the salesperson in example 1 is, now it wouldn't actually tell you that. It would depend on you to carry that over from the first part of the question. Okay? Part A. What would be the salesperson's income if he sold 150 machines? Now we are just plugging in. Y equals 300 times 150 plus 40,000. Then 300 times 150, that is going to give you 45000 or 45,000 plus 40,000. And so this person's salary per year would be $85,000, which is a ridiculously high amount of money. I can't imagine someone actually making that as a salesperson, but whatever. How many machines would the salesperson need to sell in order to earn $100,000? For this one, we're going to go back to the original equation, and we're going to set the y equal to $100,000. And then make this 300x plus 40,000. And then you just solve from there. So you subtract the 40,000 over, you get 60,000 equals 300x. Then divide by 300. Boom, boom. It's 600 divided by 3, which would be 200 machines. And that's basically it. Sometimes they might ask you to write it in a complete sentence. So you would say, like, salesperson has to sell 200 machines. Okay. The other type is it should be solved with a system of equations, but I'll show you exactly how they would set it up. It would be one where it's like, oh, let me find the perfect example for it. So this is the perfect example for that one. At a school play, children's tickets cost $3 each, and adult tickets cost $7 each. The total amount of money earned from ticket sales is equals $210. Write a linear model that relates the number of children's tickets sold to the number of adult tickets sold. So whenever we're doing this, we have to start by defining children's tickets. So I would say C is children's, and A is adult tickets. No adults has an element. So for this one, it's going to be 3C plus 7A, because children tickets cost 3, adult tickets cost 7, and that would have to equal $210. And that's all it asks you to do is write a linear model. So if it's asking for a linear model, that's all you need to do. Now in the next part it says how many children's tickets were sold. There's 24 adult tickets were sold. So now we're just plugging 24 in for A. So it'd be 3C plus 7 times 24 equals 210. 14, 16. So it's going to give you 3C plus 168 equals 210. Subtract the 168. Gives you 3C equals 32. Check my math on that. No, it should be 42. There we go. No, 32 is right. I'm just going to do it out on the side here. I can't think off the top of my head right now. It's 42. Like I said, 42. Now we divide by 3. We get C equals 3 goes into 42 14 times. There would be 14 children's tickets sold. Alright, that's the end of the lesson. It's probably a good time to stop. So it's like 2:30 in the morning. But go ahead and try the solving these linear problem solving. So you only have to do those first two pages.